Dr. Sean Lee earned a doctorate in aerospace engineering. He is one of the pioneers who studied the controls of UAVs and has worked on projects funded by the Department of Defense.
Hello, hey, thank you, El. So we're going to talk about how precision drones can help in the agriculture sector. We know that people are. It's a problem trying to get more food nowadays because of the scarcity of land, and people are. This is a valid concern about the food security. So I think this is a good technology that can help us to grow more food in a more sustainable way. So today I'll be going through 7 points. First, I'll be discussing what are drones, how agricultural drones can do, in the market insights of the agricultural drones, and the market overview, the different types of drones and services that they can provide for the agriculture sector, precision farming applications, the big data and AI, and what's our take. So first of all, what are drones? Well, when people talk about drones, right, they tend to have this perception that drones are supposed to be flying and it will be spying everything. Or you know, in the news where they say the US is using drones for warfare. But actually drones, it's a very general term for anything that is capable of moving by itself. So a robot vehicle that can navigate towards its destination on its own without the need of a human pilot, that is considered a drone. So anything like a self-driving car, tractors, UAVs, which we are very familiar with, the ones that fly, or unmanned ground vehicles are the very best examples of drones. Yeah, so Wall-E is in fact a drone, a rubbish compacting drone. And typically you will find these sensors and actuators and also the controllers in a drone. So we're going to go through some of them. We have a set of sensors like gyros and accelerometers. You have this in your smartphones too. The way that you tilt your phone and then the video automatically rotates its orientation, that's due to the gyros and accelerometers in your phone giving the input to the smartphone computer. And we have that in the drone too. It's very important. In drone, typically we have GPS for positioning estimate, barometers for altitude estimate, and LiDARs for either obstacle avoidance or altitude estimates, and cameras for us to take data or to do some obstacle avoidance algorithms. And the microcontrollers are the brains of the machine. These are computers that take very simple inputs and then there's a lot of calculations and then give outputs to the motors. So these microcontrollers will have to connect to the sensors and also the actuators, which are the motors, and then they make fine adjustments up to 400 times a second. So that's how a drone stays in the air, maintaining its balance. Well, a motor is something that is connected to a wheel or a propeller that provides the power to move the vehicle. The battery is the one that stores the energy and provides power to the motors. Finally, we have a vehicle frame that you will need to have a place to put all these things together. So you will have the frame, and if the frame looks nice, then the drone will look nice. Let's go through some of the market insights about the agriculture drone. There's a very high growth rate, 35.9% in fact. It's a CAGR by 2025. And it is predicted that the global agriculture drone market will increase up to 5.7 billion by 2025. And here is the distribution of how the drones will be used in APAC, Asia Pacific region. And we can see that most of the target is at precision farming. Almost 75% of it will be used in precision farming. So we'll go through more about what is precision farming later. For about market overview, here are some of the growth drivers and challenges. What will help agricultural drones to gain more attention and also more usage? First of all, we have an increase of population that will put a lot of pressure on the food supply. We will need to have better ways of growing our agriculture crops. And the second will be a decrease in costs of the agriculture drones. We see a huge demand, and then also the supply is able to catch up, so that is going to drive the mass manufacturing, by utilizing the economies of scale that will help to decrease the cost of the agricultural drones. And what are the challenges that we foresee? First is the safety concerns. People are quite worried about, when you have a drone that is around 40 or 50 kilograms hovering around, and if there's an accident, the consequences can be quite damaging. So the civil aviation authorities are quite concerned about this, so they are now putting out tighter regulations about this. And always, there's also a limited supply of well-trained pilots. We don't see many drone pilot jobs nowadays in the market. So I predict that the drone pilots will become one of the hottest jobs in the next 5 to 10 years. What are the agricultural drone types, and what kind of services can they do? And this is a drone flying on a paddy farm, paddy field, and it's going to spray some pesticide on it. First of all, we have the fixed-wing drones. The literal meaning of fixed wing is that the wings are fixed to the bodies. They do not rotate, and the power comes from a propeller that is placed either at the nose or at the back. The attributes of fixed wing drones are: they can fly a very long range, maybe up to 50 to 100 kilometers, not a problem. And high endurance, typically they can last much more than the multicopters. So 1 hour to 2 hours, not a problem. And they can also go very fast. So they travel in high speed. One of the drawbacks is that they need to have a runway, or you need to have a launcher in order to launch the aircraft. And the usage will be to do surveillance of large areas. So, for example, in a farmland, you can use this fixed wing to go to and fro, and then finish scanning the whole area. The second one will be something that we are quite familiar with. So these are called rotary wing drones, where the wings are actually the propellers. When it rotates, it produces lift, and then that is how the drone can take off and then maintain itself in the air. So a few attributes of the rotary wing drones: it can take off and land vertically, up and down. You don't need a runway for that. And another special thing is that this rotary wing drones, which includes multicopter, helicopter, and so on, they can hover at one place. So this is a very unique attribute that we can really make use of. And they can fly very slowly, because these guys, they do not have any stall speed. They can also carry quite heavy loads. We use these multicopters to carry pesticides for up to 30 kilograms of them at one go. And they are very small in the wingspan. In terms of wingspan, since it's a rotating wing, it's very small, and it can be very suitable for crop dusting. It's not that fixed wings cannot carry high loads, it's just that the wingspan is going to be quite huge, and that will cause a bit of problems for the farmers when they want to store it. So what can we get the best of both worlds? This is the upcoming new trend, the VTOL fixed wings. So attribute of the VTOL fixed wing drones, right? They can take off and land vertically, and while they're operating, they'll also go forward with the lift generated by the fixed wings. So they have the best of both, with a little bit of compromise, of course, because if you have 4 more motors, that increases weight, and then you have a little bit of surface area that will also increase some drag. So the fixed wing VTOL is able to fly forward like a fixed wing, and then take off and land like a multicopter. This is able to go long range with a high endurance, and also go very fast with high speed. So this is good for surveillance of large areas. Use them like a fixed wing, but take off and land like a multicopter. Very convenient. What are the types of services that an agricultural drone can do? First one will be mapping. We can use a fixed-wing drone, fly across the farm, and then take pictures, take lots of pictures of it, and then post-process them. We will use that picture to tell what's going on in the farm. The second thing after you take the picture that you need to do is the analytics. So you can actually place a lot of different kinds of payloads onto a drone. For example, in this picture, this is taken by an NDVI camera, taken by a multispectral camera, and then this type of analytics is called NDVI, where you can predict which crop is not so healthy. So the red colored ones are the ones that needs more attention. The third will be crop dusting. So this is our drone. We carry about 28 liters of fluids, and then you can fly it across the farms and do the crop dusting. This can be very helpful, and then it helps to save the manpower. It's very convenient. What are the applications of precision farming? We need a lot of engineering effort here. Based on the attributes of the drones that we have described just now, these are some of the examples that people are doing in the agricultural industry. So first of all, plant counting. When you fly across the map, when you fly across the farms, you can use the cameras to take pictures, and then it will be able to count the plants. How many trees are there in the plantation, for example? This will be all very crucial data. And you can also do weed detection. The cameras, when it's taking pictures, and after analytics, we will be able to tell whether is this a good crop or is it weed. If there is a lot of weed, then we will need to spray some herbicides to kill off the weeds, and that will help to generate more yield. The crop health monitoring and harvest monitoring, all these are the data acquisition. So we can use drones as a data acquisition tool to gather more crop health, and that will help us to predict where is the best region, and then which places need more care. So variable rate application is something that is very cool. This is a feedback system. Once we detected that this area needs more medicine or more pesticide, for example, the crop duster drone will take that input, and when it's dusting the crops, when it is applying the pesticides, it will apply less pesticide at the healthy areas, and then when it goes toward the less healthy areas, it will automatically have a higher flow, apply more pesticides at the not so healthy areas. That's why it's called a variable rate application. This is a very smart way of doing the crop dusting.
Sorry, just a reminder, 3 minutes. Thank you.
All right. And also we want to touch about big data and AI. A lot of farmlands will get a lot of different data, and then of course the supply and demand of the crops can be predicted more accurately if you have a lot of data for the machine learning. So we think that this kind of data, when it's merged with the global climate data, can also provide a better analysis of the environmental impact, and we can also achieve a better sustainability. We believe that agriculture can be improved, and by improved in many levels, if we employ the agricultural drone technology in the correct way. So we have since like 10,000 years ago, when the agriculture revolution started, we know how to plant things to survive. We don't have to go and do the gather and hunter again. We have been relying on agriculture. So this will be another next step. This will be a new step to allow us to consume in a more sustainable manner. And that's the end of my presentation. Thank you very much.